Again, warm-up number 70 is on the screen. You should be able to do all 4 of them by now. Number 1 is divide using synthetic division. 2x cubed plus x squared plus x minus 4 divided by x plus 3. Number 2, it says graph f of x equals x, f of x equals x squared, f of x equals x cubed. However, then do the transformation of g of x equals 4 times f of x plus 4, and then outside the parentheses, minus 6. Number 3, factor 3x squared plus 13x plus 4. And number 4, solve the system, negative x plus y equals 2, and x plus 3y equals 2. Give you a couple more minutes, copy and go. All right. Number 1. You go for number 1, Christian, go. I'm sorry? You kind of what? You're not sure? Okay. Help him out, Noor.
I'm very
Phil, go.
2x squared minus 5x plus 16 plus negative 52 over x plus 3.
Plus negative 52
Over
x plus 3. Hands, have you got that? That is correct. Double check your work. Number 2. For number 2, remember that there's 2 points that all functions go through. 0, 0, and 1, 1. We need this 1, 1 in order for us to do the stretch or compress. What is the 4 going to do? It's going to stretch the original functions. So instead of having 1, 1, now it's going to be what? 1, 4. So now my 2 points, once it stretches, 0, 0, and 1, 4. So now we're going to take those 2 points and move them according to this. Tell your neighbor where they're going to move, please. All right, solve. Go. 4 to the left and 6 down. That is correct. Or negative 4 and negative 6. So if this one is this one, that means we still need this point, which is 4 steps up, 1 to the right, somewhere around there, and all graphs go through those 2 points. Number 3, factors of number 3. Andy, go. All right, help him out, Thomas. Yeah. 3x plus 1. X plus 4. Hands, have you got that? Looks about right. And, yes. Oh, okay. No. All right. Number 4. Carlos, what did you get for number 4? Negative 1, 1. Hands, have you got that as a solution? That is correct. So, how do we get that? You can use elimination, yeah? This becomes 4y equals 4, divide by 4. Y equals 1, substitute that in there, you get negative 1 for x. Yes? All right, here we go. Agenda for today. Warm-up number 70, we just finished. Pop party review. By the way, those of you that are watching online, we did have a pop party at the beginning of the period, so make sure when you get back, you let me know so you can enjoy the pop party that you missed. Enjoy, get it, right? Anyway, tonight's home play is page 183. Numbers 1 through 4, comma, and pick 4. And I'll show you that from the list of problems that I'm going to show you on the screen. Now, page 183 is in Canvas in the module for quadratic equations. Once again, we already did this session, or these 2 sessions that I'm comprising into one, but it's just a review so you're ready for tomorrow's pop party. And you're saying, Mr. Q, why are we having different pop parties? Because I was going to give you just one, but I said I'm going to chunk it better so it give you a better opportunity to do a little bit better, because progress reports are coming up, yeah? I just updated the Canvas grade. Some of you are missing a lot of assignments. I don't know what you're doing. Are you a Power Ranger? I don't know. You might be. That's why you don't do any of your assignments. Oh my goodness. And by the way, that's all that's going so far in your progress report, what you've been turning in. Oh, and these pop parties. All right. So, no asynchronous code for tonight. Last night's home play was pages 165, 166. You keep that. That was for you to practice. That was your study guide. So if you did that, I'm pretty sure you did well on your pop party. All right. Tonight, take a picture of that, please. Once again, page 183, numbers 1 through 4, and then pick 4 of these 8 below. Pick 4 and do those as practice. That's going to be tomorrow's pop party. All right. You got it? Yes? All right. So, you need a Cornell note. Get a Cornell note ready. Today we're going to focus on parabolas. Parabola. You don't need a fair model because you already have it, but get a Cornell note for that. Also, could I get Did I already call the first person?
No, that was the last one.
Okay. Can I get the last person on each row? Go get a graph paper for your row. All right. There's the objective. Copy that, and we'll get that as soon as everybody. I can write in graph a quadratic equation of a parabola. So once again, we're on parabolas one more time. I'm going to do a quick review. Once again, this is on tomorrow's pop party. Okay, here we go. So what is our main concept? Parabolas. You don't need a fair model because we already covered this. What are parabolas? They're equidistant points from two things. Directrix, which is a line, and a focus. A parabola is a curve between those two equidistant points. And here's the curve on the screen. Notice that. So notice here we have the directrix, we have the focus. Now, according to what we've been doing with parabolas, when we got to this point, get it to this point, we can focus on the focus, on the point between that and the directrix known as the vertex, and then we placed a point on the directrix known as the directrix point, yes? So we were working with those three. From there, I said, there's a standard form equation that looks like this. Then I said, for Christmas break, memorize this process. Yes? Then from there, I said, here's the formal introduction for vertical parabolas and horizontal parabolas. Remember that? And I said, we're going to focus on these two. Vertical parabolas start with x squared equals 4py, and the directrix is y. Another way of thinking about it is when I give you a problem and it says that the directrix is y equals a number, so that means you look and you start writing your equation, and remember the variable y is a directrix, so you write 4py equals to x squared. This one, what is the directrix? X, so that means you think about 4px, and on the other side is y squared. All right. So from there, we did some of these problems. So copy this one, and you can do the big one, the big graph paper. So it says, write and graph the equation. Don't copy all that. All I want you to write at the top left is example 1, super Q, and then write these words, points of origin. Then you're going to write focus, 0, -3, and directrix, y equals 3. So for this problem, they're going to ask us to do two things. Write an equation and graph our parabola. So, let's see if we remember. Look at the directrix. What is the directrix for this one? Y equals 3. So which variable is it? Y, which means we need to write an equation. So what does that remind you of? Of 4py, because this is y. Y is by itself, next to 4p. So what would we write on the other side of the equation? X squared. Hopefully this is coming back. We already did these before. Here goes. So let's get started. We're going to plot our focus in red. So our focus is 0 of x, negative 3 of y. 0 of x, negative 3 of y. There it is. Our directrix, I'm going to do that in blue, is going through y equals 3. Y equals 3 is up here. So, y equals 3. There it is. And what else did they give us information of? That it's going through where? The point of origin. Plot a point there. So let's see. Look at it. Is the point of origin, or the point that's on the point of origin, the same distance from the directrix and the focus? Yes. So now we have to just graph our parabola. How do we do that, Mr. Q? Well, for these simple ones, I said let's get a table. X and y. We got negative 2, negative 1, 0, 1, 2. However, before we substitute this in here, we need to change the value for P. P is the distance between the points. 3 steps and 3 steps. However, specifically for the focus, we're going to use that value from the focus, which is what? Negative 3. What is it? Negative 3. So let's rewrite that equation. So this equation becomes x squared equals 4 times p times y, but instead of p, I'm going to write there negative 3. So the equation that we're going to use to substitute values is x squared minus 12y. Alright, so we're going to show work for 2, because they're going to reflect, and the same values are going to be for the other 2 on the positive side. Yes? There you go. So, parentheses squared equals negative 12y. So what's my first value that I'm going to substitute for x? Negative 2. So what is negative 2 squared? That's 4 equals to negative 12y. Let's solve for y. That means I divide by negative 12. So if I simplify this, this is negative. Divide top and bottom by 4, so it's 1/3. That goes right here, negative 1/3. But since it's a parabola, it's going to reflect to the other side, which is where? At x equals 2. Same value. Is it coming back for some of you? Yes? All right. Let's do the same now for the next value, which is negative 1. Parentheses squared equals negative 12y. My next value is negative 1. So what is negative 1 squared? 1 equals negative 12y. Divide by negative 12, divide by negative 12. Negative 1 over 12 equals y. That goes right here, negative 1/12. But also where? At 1, negative 1/12. And here for the point of origin is 0, 0, yes? Let's plot our points. Negative 2 and 1/3, negative. Negative 2 and negative 1/3 is about right third. Next, negative 1, negative 1/12. Negative 1, negative 1/12 is very close to the x-axis, almost touching it. Then we got 0, 0 already there. And then it's just going to reflect. This one is going to reflect over here. And this one's going to reflect over here. And there's our parabola. All right, 2 things to notice. Number 1, the parabola opens away from the directrix line. See the directrix line, the blue one? Here's the blue one. And notice the parabola is opening away. If you're opening your parabola towards the directrix, you made a mistake. The second thing to notice is that notice that it's a smooth curve. So if you end up with a zigzag here, something weird going on, you made a mistake with your computation. Okay? All right? Let's do one more. Copy this one. Example 2. You have plenty of space in the back, yeah? So once again, I want you to write, for example, 2, I want you to write the words point of origin. You're going to write the focus 5, 0, and directrix x equals -5. All right, so let's look at it. Look at the directrix. What variable is it? X. So tell your neighbor what equation we're going to write over here. What equation shall we write? So if this is x, that means you're thinking 4px, yes? Which means on the other side you have y squared. All right, let's plot our focus. What's our focus? 5, 0. 5 of x, 0 of y. 5 of x, 0 of y, which is over here. Our directrix is at x -5. -5 is right there. And you draw your line down. All right, and what else do they tell us? That it's going through where? The point of origin. So we plot our point there. Look at it. It should be equidistant, yes? Okay. So, with that said, we need a table. X, Y, but before you fill in the values, look up. Look at the previous one. Look up. We had x squared, is that correct? And we got x values to substitute in there and get our y. Let me repeat that again. We had x squared, we substituted values in there to get our y. What do we have now? Therefore, what do we need? Y value. So instead of x, we're going to substitute -2 for y, -1 for y, 0, and we know it's the point of origin 0, 0, 1, and 2. All right, so before we start substituting, we need to change this value of p. What are we going to substitute in for p right there? 5, the focus, yes, which is that one. So I'm going to write y squared equals 4 times p times x, and that value is 5. So this is y squared equals 20x. So parentheses squared equals 20x. So what's my first value for y? -2. So what is -2 squared? 4 equals 20x. Divide by 20. We end up with 1/5 equals x. Goes right here, and it goes down here. All right. Next, do that again. Squared equals 20x, but now we're going to substitute which value? -1. So what is -1 squared? 1 equals 20x. Divide by 20. So this is 1/20th equals x. Goes right here, and it goes right there. All right, for the graph on this one, make sure you keep organizing your noodle because it's going to look kind of weird. So look at this. This is 1/5 of x. So here's x. Here's 1 of x. 1/5 is about right there. However, what is its y value? -2. So that means I need to move to this spot. This spot. Next one, 1/20th. So here's 1 of x. 1/20th is very close to the point of origin, but its y value is -1, so it's about right there. We have 0, 0, and then just reflect these over here. And there you go. Fairly simple, straightforward. So what is it? What are the two things that you must know? You must know that when you look at the Directrix, you must know which equation to use. So this one had the Directrix y equals something, so I wrote 4py equals 2x squared. This one had the Directrix x equals something, so I wrote 4px, and on the other side, the y squared. That's how you know which equation to write. For p, we're going to substitute the value for the focus, which was 5, and on this one it was -3. And once again, if it has an x squared, you get values for x so that you can get your y. If it has the y squared, then you get values for y to get your x values. Okay? So far so good, yes? Good refresher? All right, let's crank it up a notch. So let's go to the next part. From there, I said, all right, guys, so quick recap, look up. We've been looking at these two, yes? And it was going through the point of origin, which was 0, 0. Our vertex was at where? 0, 0. But these next ones are no longer going to be going through 0, 0. That's why we need to add two parameters, h and k, for both of them. But you got to remember that h always goes with the x. Look at this one over here. H always goes with the x. And k always goes with the y. So if I was to give you a Directrix and the equation whatever, the first thing you're going to think is something like this, but since it's no longer going through the point of origin, you have to rewrite it like this. Copy this one, example 1 supercube. Only copy the focus and the Directrix. The focus and the Directrix. So let's see. Look at the Directrix. Y equals something. So if this was going through the point of origin, which is not, but if it was, what would be our equation for Directrix y? It would be what? 4py equals 2x squared. Is that correct? Yes? Yes. But notice, does it say point of origin? No, which means now we need to rewrite this as a bigger equation. Here's the x squared equals to 4p, and there's the y. You guys see it's the same thing? But what goes next to the x? Minus h, and how about the y? Minus k. That's how you rewrite those. All right? All right, so let's see if you remember these. I said, let's keep organized. At the top, I want you to write focus in red, V for vertex in green, D for Directrix point, and we're going to need a value for P, which is known as the distance between the points. And how do we find that? We're going to subtract two distances and divide by 2. And that's going to give us the steps away from each of the points. Bless you. Bless you. All right, let's begin. With red, let's plot our focus. 4, 5. 4, 5. And write it right here. 4, 5. What's our Directrix? Our Directrix is y equals 1. Y equals 1 is right there. There's our line. Now let me show you one mistake that I saw on some of your home play. Some of you, when you wrote here the coordinate for the Directrix, some of you wrote that one with 0 of x. That is incorrect. You need to follow the focus straight to the Directrix and place your new point. What is our new point? 4, 1. So that goes right there. And why do we need that, Mr. Q? Because now we can see what both points have in common. Look at it. Look at the coordinates. What do both points have in common? The 4. That means the vertex also has a 4. Since the vertex is no longer at 0, 0, our vertex now is h and k. We already have h, now we need to find k. How do we find k? Well, you take the y value of the focus and subtract p, which is the distance between the points. Not these two, but between each of the points. Remember, there's an invisible point there that we still haven't plotted yet. How do we find that, Mr. Q? Well, we have right now these two, so we need to subtract two distances. Shall we subtract 4 from 4? No. 5 and 1. So 5 minus 1 is 4. But we need to divide it by 2 because it's two distances. So what's 4 divided by 2? 2. That's P. Now that we know what P is, that goes right there. So that's 2 minus my y value of the focus. So, to get k, that is 3. So let's plot our point and see if it's between the points. 4, 3. Look at it. Is it 2 steps away from each other? Yeah, because that's what we got here, yes? 1, 2, 1, 2. Yeah, 2 steps from each other. Can we graph our parabola already? Yes. For this one, we don't need a table, so just graph your parabola. It has to be away from the directrix. All right? Am I done? No. The last step is to rewrite our equation. So I'm going to write x minus blank squared, 4 times blank, y minus blank. All right? So, with that said, all we have to do is substitute. Tell your neighbor what h and k are. What are h and k? H and K. Miguel, go. 4 and 3, yes. How about P, everyone? What is P? 2. And then we just rewrite this. X minus 4 squared equals 8, y minus 3. That's our standard form equation of a parabola.
That is correct.
It's right there.
Y minus 3, right?
No, that's for the circle. This is a parabola. The parabola, only one variable has a square. Are we doing? Yes? Let's do another one just to make sure we got it. Here we go. If you want to do the work on your Cornell notes. Copy this one. Focus 5, 4, directrix x equals 1. Focus 5, 4, directrix x equals 1. All right. By looking at the directrix, it says what? X equals something, yes? So if it was going to the point of origin, what would be my first equation that I would think of? 4px equals to what? Y squared, yes? However, does it say point of origin here? No, that means we need to rewrite a bigger equation. We have y squared equals 4px. So what goes next to the y? Minus k, and next to the x, minus h. All right? Focus, vertex, directrix. Once again, we still need to find the distance between the points. Divide by 2. That's how we get our distance. So, focus, 5, 4. Directrix, x equals 1. However, follow the focus all the way to the directrix, plot your point, so now that's my what? My new point, which is 1, 4. 1, 4. Look at those two, what do they have in common now? The 4, so here, for the vertex, I place a 4. Remember, the vertex is H and K, so that means we already have K. What do we need now? H. How to find H? Now we need the X value of the focus subtracted from P. How do we find P? Subtract this from this. 5 minus 1 is 4. 4 divided by 2 is 2. That goes there. X value of the focus is 5. So to find H, that is 3. 3, 4, parabola. And you know what to do to rewrite this, yes? Alright guys, once again, do your home play. Those two examples are going to be the ones for tomorrow's pop party. Have a good one. See you guys tomorrow. Bye.